Okay, here's the notes for 3.3 today. Basically, we're going to continue with one-step inequalities, but we're going to focus on multiplication and division. And the reason this is separate from addition and subtraction is because when you deal with inequalities, you have to be very careful when you deal with negatives because there's an extra step you have to do. And some of you may also remember this because your teachers last year may have showed you. So go ahead and title your notes if you haven't done so. 3.3, one-step inequalities, multiplication and division. So here we go. Basically, we're still dealing with equivalent inequalities, okay, inequalities that have the same solution set. However, the biggest thing for today, and this is what you're going to write down, this is our main key concept, is when multiplying or dividing by a negative number, you must reverse the inequality symbol to keep it true. You need to multiply that, or excuse me, you need to write that down and you need to highlight it in your notes right now. You have 1 minute, pause the video. Okay, this is the main idea of today. Whenever you multiply or divide by a negative number, you must reverse the inequality. If you don't, you end up with a false statement. And now I'm going to do the best I can to show you why we do that, okay? So before we get to that, remember, the whole idea is we're isolating our variable, we're going to balance our inequality by doing whatever we do to one side, we do to the other side, and then we're going to use our inverse operations to solve. Remember, this is set builder notation and set notation. You don't have to use this notation, but it is there. It is something you will use later. Now, this is the idea of when you're using positive numbers, okay? So whenever you multiply, whatever you do to one side, you do to the other. Whatever you divide, whatever you do to one side, you do to the other. Those are basic inverse operations. We've been doing those. So this is nothing new. Alright, we have two examples, and then we are going to do practices because we basically have two examples with positives, two examples with negatives, and then practices in between. So we're going to start with the first one. So you can just call this example 1 and example 2, that's fine. Or you can call this like the positive examples, that's fine too. Okay, so here we go. First one. Now this is 3x greater than negative 27. So we're going to divide by 3 on both sides because that's a product. So these divide, so we get x greater than negative 9. Now, we divided by a positive number. Now, the fact that we got a negative over here doesn't matter. Okay? The fact that we divided by a positive means we do not change our inequality. So our answer is x greater than negative 9. And of course, we're going to do our graph. We have negative 9, negative 10, negative 8. So it's x greater than that. So open circle to the right. Okay, the second one with the fraction. Now, this one, I'm going to show you something. Okay. When you have a fraction that is your coefficient, now I told you this last week, you're going to multiply by its reciprocal on both sides. Okay, and the reason we do that is what do we get right here? We get 6 over 6, which is really 1. Remember I showed you this? This is that really big 1. So really what we have is r less than. Now let's actually figure this out. Let's put this under a 1. Multiply across. 6 times 3 is 18. 1 times 2 is 2. 18 divided by 2 is 9. Now, we multiplied by 3 over 2, but it was positive, right? So the inequality stays the same. You do not change it. And we have a positive answer, that's fine. So we get r less than 9. So we draw our graph, so put 9 in the middle, 10, 8. It's open circle to the left. Okay, so those are your positive examples. Okay, those are both single step equations. Here we divided, here we multiplied by the reciprocal. Okay. So, and then those were the graphs we did. Okay, here's your practice. Go ahead and put 2 minutes. You have 2 minutes. Pick 2 of them. I'm going to do all 3. Remember the difference between A, B, and C, so you decide what level you'd like to do. So go ahead and pause the video now. Alright, you've had a chance to try 2 of these. If you got 3 of them done, that's awesome. Hopefully you got at least 1 done. So now I'm going to go ahead and go through each and every one of these. So on this one right here, I'd divide by 4, and I would get k greater than 6. And my graph, or my inequality, my number line would look like this. Okay. B. Q is reversed. That's fine. So we're still going to divide by 5. I get negative 10 greater than or equal to Q. Now remember what I talked about in the last series with 3.1 and 3.2. We want the variable first. So we can swap these, but I must flip my inequality. Now I'm not flipping my inequality because the 10 is negative. I don't want you to get confused. In this instance only, I'm flipping it because my Q is second. I want my Q first. Then I flip my inequality, and then I want my number second. Okay? So Q is less than or equal to negative 10, so let's do our graph. Let's see, less than or equal to, so that's closed circle to the left. And by the way, I didn't mention this last time, if you want to use colored pencils on your homework to do your graphs, you're more than welcome to do that. I highly recommend it actually, or highlighters, go right ahead. Okay, last one with the fraction. I'm sure some of you were brave and tried it. Okay. Now remember, if you have a fraction that is a coefficient, multiply by its reciprocal on both sides. So right here, I'm going to get 12 over 12, which is 1. So I get G greater than. Now I'm actually going to cross cancel here. I could multiply across. For those of you that did that, you do 27 times 4, you get 108, okay? You'd get 108 over 3, you would divide 3 in, and you would get 36. Or, for those of you that know how to cross cancel, you could make that a 1, and that's a 9, and you get 9 times 4 is 36. Either way, you get G greater than 36. So we have 36, 37, 35. And then we have a greater than, so open circle on 36 to the right. Okay? So hopefully you got yours right. If you didn't, hopefully you can see the mistake you made. Okay, now in every single one of these cases so far, when I did my inverse operation, I did it with a positive number. Okay? And in doing so, I did not have to flip my inequality. See, I divided by positive 4 here, I divided by positive 5 there, I multiplied by a positive 4/3 here. In B, the only reason I flipped my inequality is because my answer was backwards. Okay? Now we're going to get into the negative stuff. Now, when you do your negatives, okay, you still got to make sure you do both sides, okay, with that negative value. Now, here's where it's going to get a little confusing. This is why, or let's see what happens, when you actually multiply divide by negative numbers. So, let's just put some numbers up here, okay? So let's say this is like negative 5, and this is a negative 2, and this is positive 2, and this is positive 5, okay? Now, let's look at what this is saying. This says right now A is less than B. Now, we agree, right? A is less than B on the number line. You see how A is closer to 0? That means it's a smaller value. So just like if we gave it 2, we could say 2 is less than 5. Okay? Now, what happens if we multiply both of these by a negative 1? Well, then they both turn negative, right? So when you multiply, if they're positive, when you multiply by negative, look what happens. They shift to the other side. If we cut the number line in half down 0, they shift to the negative side. Do you see that? Well, on the negative side, things that are farther from 0 are less than things that are closer to 0, right? Well, if A is less than B on the positive side, is that true on the negative side when you multiply them both by a negative 1? Well, no. If you look at the number line, you see how the negative A is actually negative 2, which is closer to 0 than negative B. In this case, what happens is when you multiply by a negative, you actually reverse the roles. On the positive side, A is less than B. Okay, but when you flip it over here, negative A is not less than negative B. In fact, negative A is bigger than negative B because it's on the negative side. So that's why we had to flip the inequality, because when you multiply by a negative, you would go from one side to the other and the rules are opposite. Let's look at this case right here. This says b is greater than negative a. Well, that's obvious because b is positive and a is negative, right? And positives are always bigger than negatives. Well, what if we were to multiply both of these by a -1? Well, the b would turn negative, the a would turn positive. So what would happen? Well, when you look at your number line, what's the relationship between negative b and positive a? Well, if you notice, negative b is now less than positive a. So you have to say it so. It started out greater than on this side, but once you multiply, it flips. So whenever you multiply or divide by a negative number, you're actually reversing the roles of the values. So you have to flip the inequality to accommodate that. Okay, I know this is confusing. This is probably, no joke, this is probably the very first time you've seen an explanation as to why you have to do this. Okay, so I understand it's, some of you might get it, some of you may not. Okay, do the best that you can. All right, so now let's actually try this. We have two examples. Now, these are our negative examples, meaning we're going to deal with a negative number to isolate. So we're going to start with the first one, negative 8x greater than 72. So we're going to divide by negative 8. So we get x, and then 72 divided by negative 8 is negative 9. Now, the fact that this is negative 9 does not mean we have to flip this. The reason we flipped the inequality is because we divided by a negative 8. So this turns to less than. So x is less than negative 9. So let's do our graph. Less than means open circle to the left. Okay, this one is tricky. I'm going to show you a little method with this guy. Okay, that's why I cleared my screen just now. I'm actually going to rewrite him on the other slide. Negative 3 less than or equal to x over negative 5. I'm pretty sure that's what it was, right? Yep, okay. All right, now, first off, not only is it backwards, see how x is on the right and the constant's on the left, but it's not your typical fraction. Now you remember this example here, let me go back a little bit, or this problem right here where the fraction stuck out and then the variable is next to it. It's pretty obvious to see a reciprocal, huh? And just like on this one here, it's very obvious to see what your fraction was. It sticks out. This one, the fraction is hidden. Watch what I do. This is technically a 1x. So I'm going to write that 1. I'm going to show it, make it visible. Okay. And now what I'm going to do is make my fraction stick out just like my other ones. Okay, you see my fraction? Now it's sticking out. Just like we had in this problem here and just like in the example. So now we can clearly see what our reciprocal is going to be. So what I'm going to do, because now I know I'm going to multiply by the reciprocal of this on both sides, right? So I'm going to leave myself a little bit of space here. So let me leave myself some space. I'm going to put my negative 1/5 x. Now, we're taking the negative with us on both sides. So the reciprocal of negative 1/5 is negative 5 over 1. So multiply the same thing on both sides. Now right here, you get 5 over 5, which is 1. So we bring down the x greater than or equal to, now negative 5 times negative 3 is a positive 15. Now remember, I want my variable first. Now, if you noticed, okay, this actually should be flipped, right? Because I multiplied by a negative number, this flips to a greater than or equal to. But I now have to flip it again because my variable is backwards. Notice what happens. See how it's the same as the original? The reason that happened is because we flipped it 2 times. We flipped it once here because of the multiplying by the negative, and then we had to flip it again because it was backwards. Sometimes that happens. You may end up with the original problem if you flip it 2 times. Okay? So then of course we do our graph. Let's see, this is going to be closed circle to the left because it's less than or equal to. Okay? Alrighty. Hopefully you have that down. Now, just like last time, I'm going to give you some practice. There's those. Okay, you have 3. Pick 2. Go ahead and pause the video. You have 2 minutes. Do as many as you can. Alright, now let's go over these. So I'm going to go through them. So starting with A, remember it's ABC. Divide by negative 12, divide by negative 12. I get x less than, because I divided by a negative. And let's see, I believe 84 divided by 12 is 7. So we get x less than 7. So I'm going to do my graph. So less than, so it is open circle to the left. Okay. B. Now, this is like the one I just got done showing you. Okay, so what I'm going to do is I'm going to show this one. There it is. I'm going to rewrite it. Let me make that better. That doesn't look like a very good negative 8. I'm going to rewrite it where my fraction sticks out so I can see it. Okay. Now I'm going to give myself some space so I can do my reciprocal. Now some of you are probably sitting there going, wow, this is a lot of writing and stuff. I don't want to have to do all this writing. Well, you got to get over that, because notice I'm taking my time, I'm doing more writing, but I'm getting it right. Okay, and I'm understanding it. That's the whole purpose behind this. So I'm going to do my reciprocal. And I do my reciprocal, so right here I get negative 3 over negative 3, which is a positive 1. So I get x. Now I multiplied by a negative number, right? So I flip my inequality. Negative 3 times negative 8 is a positive 24. But now these are backwards, so I'm going to flip it again. And because I flipped it 2 times, it goes back to the original. And then I'm going to do my graph. I'll just do it over here. 24, 25, 23, and we have closed circle to the left. Alright, decimal time. Now, if you don't mind dividing by decimals, you can leave it this way. If you don't like to divide by decimals, then you can multiply this by 100 and you can clear it. So let's actually go ahead and just clear this decimals. Clear the decimals here. So we can just do the basic division. So in this case, they both have hundredths placed, so we're going to multiply the whole thing by 100. So that means this moves 2 times. So we're going to get, let's see, 425 is greater than 25h, negative 25h, right? Okay, so now I can see I'm going to divide by negative 25 on both sides. Okay, so I'm going to get h, and then my inequality flips, not because this is going to end up negative, but because I divided by a negative number. So off to the side here, let's do 25 into 425. Okay, well 2 25s is 50, and there's no way, so I could do 125 right here. So let's subtract, that's a 3, boom, that's 1, that's 75. Okay, so 175. So this is like $1.75. So this is asking us how many quarters are $1.75. Well, 4 quarters is 100. 5 quarters is 125. 6 quarters is 150. And then, so 7 quarters is 175. So 17. So we're going to flip it again because my variable it's backwards. So I ended up with the original, which is fine. So here I get my graph, 17, 18, 16, and it is greater than, so on 17, open circle to the right. Okay, so hopefully you got these right. If you didn't, then hopefully you figured out what you did wrong. The main idea for today is when you multiply or divide by a negative number, you must flip your inequality. Now, that's not the same as when you go to multiply or divide, regardless of whether it's positive or negative, if you end up with a negative answer, that doesn't mean you flip the inequality. It just means you have a negative answer, and that's fine. Okay? Now, That's it. We're done. So what you're going to do is work on your 3-3 practice. Okay? And when you're working on this, notice you have number lines. Okay? Notice you do have some fractions in here. You do have a decimal. You can decide how you want to do that. And you do have a couple word problems. I want you to try to figure those out. I didn't do any word problems with this, but see what you can do. Okay? And then you do have number lines, so you can make up your number lines, and that's fine. Alright, so you're working on this, and this is what's going to be due as part of your homework. Okay? So, there it is. Good luck.